So we're continuing on learning target 3A. We've learned how to calculate slope, and we've learned how the relationship between slope and rate of change. Okay, so today we are continuing, and we're going to talk about how we graph linear functions, how we graph lines on a plane. Okay, so we're going to turn a couple of pages. We're going to do intercepts another day, so keep moving. Okay. So we're going to turn to where it says graphing slope-intercept form. Okay, so just a refresher, I put slope-intercept form here. The reason why it's called that is because we're given the slope and the intercept. Okay, so you should remember that here in our formula or our equation, m here represents our slope. Okay, that's our rise over run, that's our rate of change. Okay, b represents our y-intercept. Okay. And for those of us who forgot, a y-intercept is where the graph touches or crosses the y-axis. Right, so y equals mx plus b. Okay, so here I want you to write the equation in slope-intercept form given the following slope and y-intercept. So here I have a slope of 3/4. I have a y-intercept of -2. Okay, write it for me in slope-intercept form. Okay, so you should have gotten y equals 3/4 x minus 2. Okay. So you should have plugged in the 3/4 here for m in your slope, okay, and then you should have plugged in -2 here for your b, right? So instead of writing plus -2, we just write -2. Okay, so can you guys try this one? Here your slope is -3, your y-intercept is 4. Okay, you should have gotten y equals -3x plus 4. You should have plugged in -3 here for m as your slope. Okay. And you should have plugged in this 4 in for b. Okay. So y equals -3x plus 4. Okay. The reason why we're reviewing slope-intercept form is because we're going to use the slope and the y-intercept to graph. Okay. So in order to graph any line, you need 2 points. Okay. So the first point that we're going to plot is b, our y-intercept. Okay, so you're going to use b and plot your y-intercept. Okay. And again, your y-intercept is where the graph touches the y-axis. Okay. Then step 2, you're going to plot the second point, and you're going to use slope, right, with rise over run. Okay. The top, the numerator is rise, so you're going to either count up or down, okay, depending on the sign. Okay. So you're going to count up if your sign is positive. You're going to count down if your point is negative. Okay. And then for your denominator, you're going to count that many spaces to the right. Okay. You plot that point, and then your step 3 is to draw the line. Please use a ruler. Okay. Use a ruler. Okay, that line should be straight. Okay. The reason why is because towards the end of the semester, when we talk about systems, we use our line, and it has to be accurate in order to solve. Okay, okay, so let's go. Okay, so here we're graphing the following equations. Y equals 3/4 x minus 2. Okay. Please notice that your b, or your y-intercept, is -2, and your slope is positive 3/4. All right. According to the directions, I'm going to plot my first point using b, my y-intercept, so that's -2. Okay, so here's the y-axis. I'm going to place a point at -2. Okay. This here is my b. Then I'm going to plot the second point using slope, rise over run. Okay, so my numerator, that's the top number. So I either count up or down depending on the sign. Since this is a positive, I'm going to count up 3. Okay, so this means up 3. Okay, so here I'm going to go up 3. 1, 2, 3. And then the denominator, the number on the bottom, I'm going to count right. So I'm going to go right 4. Okay, so up 3, 1, 2, 3, right 4. 1, 2, 3, 4. Okay. Then I'm going to use my ruler to connect. Okay. The further and further we get from our 2 points, sometimes it gets less and less accurate because our ruler isn't good or something like that. So please be careful. Okay, make sure you're going directly through those points. Okay, and so here is my line. Here's the next one, y equals negative 3x plus 4. Okay, so I'm going to find my slope. Okay, my slope here is negative 3. Okay, or another way to say it is negative 3 over 1. Okay. And then my y-intercept, my b here is 4. So the first thing I'm going to do is plot my y-intercept. Okay, so that's 4. Here's my y-axis. So my y-intercept is here, 4. Okay. Then, step 2, I'm going to use the slope to graph the next point. Okay, so since this is a negative 3, right, this means I'm going to go down 3 and right 1. Okay, the denominator always right. Okay, the sign affects whether it's up or down. Okay, so I'm going to go down 3, 1, 2, 3, and over 1. Okay, and all you need is 2 points to graph any line. Okay, so I'm going to connect my dots. Okay, again, I'm telling you that as we get further and further away from those 2 dots, sometimes it gets less and less accurate. Okay, so please be careful, make sure it's right. Right, so sometimes even to be careful, like I would even do it a couple more times. Okay. There you go. Sometimes, though, the equation isn't in slope-intercept form, right? For example, here I have negative 3x plus 2y equals 6. It's not in slope-intercept form, so what can we do about that? Okay? So one thing we can do is that we can change to slope-intercept form. Okay? And we actually learned how to do that a couple of days ago. Right, so we can change to slope-intercept form by solving for y. And that's what we're going to do. Okay, so let's flip it over. Okay. So here, I have negative 3x plus 2y equals 6. It is not in slope-intercept form, so here I am going to solve for y. Right? So solve for y. So I'm going to move this negative 3x over first, because this is minus 3x. Okay, I'm going to add 3x to both sides. This simplifies to 0, right? Negative 3, 0. So 0 plus 2y is just 2y. Okay. You cannot combine these. They are not like terms, so you just write it separately. Since I want mx plus b, I'm going to write the 3x first. Okay, and this is a positive 6. Then, my y is still not by itself. Okay, this is 2 times y, so to get rid of the times, I'm going to divide. So y equals 3 divided by 2 is 3/2, so 3/2 x. Okay. Right, the x is already being divided by 2 here. Right. And then 6 divided by 2 is 3. Okay. So this is it in slope-intercept form now. Okay. You should be able to identify that your slope is 3/2, your y-intercept or your b is 3. Okay. So I'm going to start by graphing my y-intercept at 3. Okay. So y-axis, y-intercept. Okay. Then I'm going to use my slope to graph. Okay, so positive, so that means I'm going to go up 3, okay, and always right, to the right 2. Okay, so I'm going to go up 3, 1, 2, 3, to the right 2, 1, 2. Okay. All you need is 2 points to graph a line. Okay. Connect. And there's my graph. Okay. I'm going to try one more before I have you do one on your own. Okay, so again, this is not slope-intercept form. We call this standard form. Okay. So again, I'm going to solve for y. Right? And the reason why is because that makes it into slope-intercept form. Okay. So I'm going to start moving this 2x. This is a positive 2x. Right, so I'm going to subtract 2x. Okay. 2x minus 2x is 0, so 0 plus 5y is 5y. Okay. Again, you cannot combine these. These are not like terms. This is a constant. This has an x to the power of 1. Okay, so negative 2x plus 10. Okay. Y is still not by itself. It's 5 times y, so I get rid of the 5 by doing the opposite, divide. Okay. Negative 2x over 5 is negative 2/5 x. Okay. And then 10 divided by 5 is 2. Okay. Now, I know that my slope is negative 2/5. And I know that my y-intercept is 2. Okay. So now I can graph using my y-intercept and my slope. Okay, so start with my y-intercept at 2. Because it was negative, that means I'm going to go down 2. Okay, and again, always to the right. Okay. So down 2, 1, 2, right 5. 1, 2, 3, 4, 5. Okay. Again, you only need 2 points to graph any line. Okay, you learn about that more in geometry. Okay. Connect and connect. There you go. Okay, I'm going to have you try this one on your own. Okay, so change it into slope-intercept form by solving for y. Okay, and then graph it. Okay, so this is what you should have gotten. First, you subtract 3x on both sides, right? Since this is a positive 3x, subtract. You get negative 4y, don't forget your negative sign, equals negative 3x plus 20. Again, you cannot combine them. This is a constant. This has x to the power of 1. Okay, then, since this is negative 4 times y, I divide by negative 4. Negative 3 divided by negative 4 becomes positive 3/4. And 20 divided by negative 4 is negative 5. Okay. From here, my slope is 3/4. I'm going up 3, right 4. My y-intercept is negative 5. So I started with my y-intercept at negative 5. Then, based on my slope, since it's positive, I go up. Okay, so that's why I go up 3, right 4, and then I connect my dots. Okay. So let's do one more question here. Okay. So on rare occasions, we have to modify when counting the slopes when it hits the edge of my graph. Okay. So one example is right here where I have y equals 5x plus 7. Okay. So what you should notice is that my slope here is 5 over 2. Okay. My y-intercept, my b in this case, is 7. Okay. So let's start. Okay. So I'm going to start with my y-intercept here at 7. Right. And so normally, right, since this is positive, that means I'm going up 5, right, and always right 2. But if you notice, I cannot go up 5, 1, 2, 3, because then I end up being off the graph. Okay? When this happens, then we're going to do the opposite. So instead of up 5, I'm going to go down 5. Okay? Instead of going right 2, I'm going to go left 2. Okay, so know how I flipped both of these? Right, so instead of going up, I'm going down. Instead of going right, I'm going left. Okay, so here, I'm going to go down 5. 1, 2, 3, 4, 5. 1, 2. Right? Then I can connect. And then connect. Right. The reason why I paused here is because I wanted to make sure it was super accurate, that it continued hitting the points that I wanted. Okay, so you can see that going down 5, left 2 is the same as me going up 5, right 2. So when counting the slope hits the edge of the graph, right, we're going to do the opposite for both. Okay. So that's it on graphing slope-intercept form. Okay. Hope you have a great rest of the day, guys. Bye.